Hello everyone, this is Professor Lee. Let's solve this problem. In this problem, we have to find the reactions at D and E. And also we see several members are connected to construct a structure, and therefore our strategy must be frames and machines topic strategy. Therefore we have to be ready to disassemble the members strategically to find the reactions. Let's take care of the given information first. C is given as pin and smooth slot, and we do know what will be the reactions from the pin smooth slot, normal to the slot surface. And smooth means we're not going to consider the friction effect from the slot surface. And A and E is the pin support. Pin support will not allow translations in X and Y directions in this two-dimensional space, but will allow rotation in clockwise or counterclockwise in this two-dimensional space. And also D is the roller. Therefore, normal to the surface, one reaction from the D. So therefore, we have to find one reaction from the roller in Y direction and two reactions at E. Let's start our solutions. So let's define our coordinates first. So since we're dealing with a two-dimensional space, we need these two axes, and definitely we need a moment. These directions are going to be our positive directions. So to find the reactions at D and E, let's take care of where they are in our body here. Definitely, we have to disassemble member AC and the member BCDE. Therefore, we need two free body diagrams for these two members. Let's start our free body diagrams. So we're gonna draw free body diagram for these two members. So let's draw the free body diagram for the member AC first. So member AC. Here, one active force is acting clockwise directions. How much? 600 pound-feet. Then we have to move to the reaction force. So reactions at pin 1, 2. In terms of arrows, we don't know, so let's temporarily set, and then let's label A of X and A of Y. And then let's move to the point C. Point C is a smooth slot, therefore normal to the surface. Normal to the slot surface is here. So therefore this must be normal. In terms of the direction, can be towards C or outward C. Let's start from this direction for the member AC. So that will be arrow direction. Temporarily we will set. But this we do know must be perpendicular to the slot surface. And then let's label this one as N of C. Since N of C is inclined with an angle, we have to provide angle or dimension information to identify the slope information. Looking at the given information, we don't have any angle information. Instead, we do have dimensions information. Our strategy to resolve N of C into X and Y information, we're going to use proportion information. Horizontal is 3 and vertical 4, therefore hypotenuse must be 5. But the challenging part is A of C is not straightforward. A of C is also inclined compared to the N of C, but we do know A of C and N of C, they must be perpendicular to each other. We have to be very careful to take care of this geometric information to get the slope proportion information. Coming back to the theta, to be clear, how we can utilize this given information. In this right triangle, and then theta is here in this right triangle, and therefore this angle in this blue right triangle must be 90 minus theta. But we actually do know this angle must be a right angle because N of C is acting perpendicular to the slot surface. So therefore this must be a right angle. Therefore we do see to be the right angle, this angle in this green right triangle, that angle must be theta. And therefore to use the slope information we just have from the blue right triangle, theta opposite side should be 4. Therefore theta is here. Therefore opposite side the proportion must be 4. Horizontal must be 4 and vertical must be 3 for this triangle. And therefore hypotenuse here must be 5. That's the challenging part, but we took care of very carefully. Let's don't forget the geometric information here. The length of AC, this length, 3 is horizontal is given, vertical 4 feet is given, therefore hypotenuse must be 5 feet. So we do directly indicate AC length must be 5 feet from the given information. Then let's move to member B, C, D, E. Let's take care of the reactions at point C first, because at point C, the members are connected. Therefore, Newton's third law of motion must be there, action and reaction. When we deal with the N of C with the member AC, the arrow direction was temporary here. However, when we indicate the arrows for this member BCDE, we don't have any option. According to the Newton's third law of motion, opposite direction, therefore the arrow must be in this direction. And then same magnitude, N of C, and we found the slope information here. Let's copy this one finding. Horizontal must be 4, 3, and hypotenuse was 5. This was the only challenging part, and others will be very straightforward. So let's coming back to the active force. Since we do have an active force at point B, 1 downward 500 pounds. Let's switch the color to the green to take care of other remaining reaction forces at point D first. Point D should be roller, therefore one reaction D of Y. The roller will allow translation in this horizontal direction, also will allow rotation, however will not allow this jumping up and down due to the structure of the design. So therefore one reaction at D of Y. Let's move to point E, pin support. Pin will not allow translations in X and Y, but will allow rotation in this direction. Therefore, we do have two reactions in X and Y. In terms of arrows, we don't know, so temporarily let's set this direction, and then let's label E of X and E of Y. Since I already put the dimensional information, this will be our free body diagrams for these two members. Once we have free body diagrams, it's time to apply equilibrium equations. We're going to strategically select the free body diagram to find those reactions. So first of all, to find the N of C here, this free body diagram regarding member AC will be more efficient because we only can have N of C unknowns if we are taking moment about point A. Alright, to find the N of C, let's use this free body diagram regarding member AC and apply moment about point A. So summation of all the moments about point A will be 0. So let's start from point A. A of X, A of Y will not create point A because they're passing through the point A. Therefore, we will have no moment arm. That is why we chose moment about point A. But we do have a 600 clockwise direction according to our coordinate definition here. We set the counterclockwise as positive, therefore clockwise will be opposite direction, therefore minus 600. Then let's move to point C. Point C, we have N of C. Looking at N of C and the given geometry information, which is 5 feet, if we are using this rotated coordinate system, we can actually directly use this 5 feet as the moment arm because 5 feet is perpendicular to the N of C for the geometric structure we already identified from the previous step. Therefore, 5 feet will be the moment arm for the N of C from the point A. Why? Because definition of the moment arm is perpendicular distance from A to the line of action, exactly 5 feet. Therefore, moment arm for the N of C from the point A will be the 5 feet. And absolute value, N of C, that's what we have to find. And then let's apply right-hand rule. Starting from point A, place your 4 fingers onto the moment arm. How we can call? We can call with this counterclockwise direction, therefore plus. They must be balanced. One unknown, one equations, we can directly find this N of C as 120 pounds. It is positive, means the same direction as we set in the free body diagram. Then let's move to find the D of Y. To find the D of Y, we have to move to the free body diagram for the member B, C, D, E. To find the D of Y, if we apply equilibrium equations moment about point E, then we don't need to account for the reactions at point E. Let's apply moment about point E equal to B0. So we're going to start from point E, then let's move to the left. E of x, E of y, they cannot create the moment because they are passing through. That is why we chose point E for this moment consideration. And then let's move to point D. Point D, D of y, will create the moment above point E. Then who is the moment arm? 2 feet, because perpendicular distance from point E to the line of action, which is D of y. Therefore, 2 feet will be the moment arm. Multiply the absolute value of the force, therefore D of y. Then let's apply the right hand rule. Starting from point E, then place your right four fingers. How we can call this D of y? It must be thumbs down posture, therefore minus. Then let's move to point C. N of C is inclined with this slope information 3, 4, 5. We're going to resolve this one into x and y. N of C, the horizontal component, will not create the moment above point E because it is passing through the point E for our moment consideration. However, the y component of N of C will create the moment above point E. Who will be the moment arm? Perpendicular distance from point E to the line of action of y component of N of C, therefore 2 plus 3. 5 feet will be the moment arm. Then we have to multiply by the absolute value y component. 3 over 5 times N of C will be the absolute value of the N of C y component. And then let's apply right hand rule. Starting from point E, place your right four fingers. It should be thumbs up posture. We can call, therefore, positive. And let's move to point B. We do have 500 pounds. Yes, this vertical 500 will create the moment above point E. Then who is the moment arm? Starting from point E, perpendicular to the line of action of the 500, 2 plus 3 plus 3, therefore 8 feet will be the moment arm. Absolute value of the force, therefore 500. Then let's apply right hand rule. Starting from point E, place your four fingers. How we can call? Thumbs up posture, therefore positive. They must be balanced. One unknown, one equation. Since we found N of C from the previous step, we can directly find the D of Y from this equations. It's going to be positive 2180 pounds. Lastly, to find the E of X, E of Y, we can directly apply Fx equal to be 0, Fy equal to be 0. Fx equal to be 0 to find the E of X first. Starting from B, then let's move to E. So at B, no horizontal direction, then let's move to C. Yes, C horizontal, therefore we have to read 4 over 5 N of C, and the direction was positive. Let's move to point D. No, because upward. Point E, yes, E of X positive, because we set as temporarily E of X horizontal right direction. That's our positive direction. N of C, again, we found from the previous steps. Substituting that information, E of X will be minus 96 pounds. Minus means opposite direction, as we said in the free body diagram. So how we can interpret? So to be in equilibrium in this horizontal direction, E of X must actually left horizontal direction. That way, the body can be in equilibrium. How much? 96 pounds must be applied. Let's keep working. So we're going to apply Fy equal to be 0 to find the E of Y. Let's start from again, point B. Point B, we have minus 500. Then let's move to next, downward. So we have to read the vertical direction at point C, therefore 3 over 5 N of C. Downward, therefore minus. Let's move to point D, upward D of Y, and then upward point E of Y. Both are positive. D of Y plus E of Y. They must be balanced. We already found D of Y from the previous step. We can substitute N of C. Also, we can substitute. Therefore, one unknown, one equations. We can find the E of Y from these equations directly. It's going to be, again, minus 1608 pounds. It's minus to make in equilibrium. E of Y actually must be downward direction, how much? This is 16.08 pounds much. That's what we found. Let's take care of final answer information. Following the 3-6 rule, D of Y, let's use kilopounds, 2.18 KIP, kilopounds. E of X is minus 96.0 pounds, and the E of Y is, we're going to round off here, minus 1.61 kilopounds. And we do know how to interpret these positive, negative signs. So again, positive sign means same direction as we set in the free body diagram, but negative sign means opposite direction as we set in the free body diagram. That's how to interpret the signs from the answers. Thank you everyone. See you next time.